medical classification. So this is certain case study. So we have seen the various deep learning application in various medical image processing. Now we'll talk about whatever the work done in terms of medical image analysis using AI. So first we'll see brain tumor detection using various machine learning based algorithms. So the idea of this problem is to develop a model. In this model, we have utilized support vector machine, SVM, logistic regression, CN. These three models have been utilized for given data set which has MRI images. And by using data set, we can give the accurate prediction whether the tumor is hereditary or known tumors. So first of all, we need to know how we can choose the right algorithm or perfect algorithm. That means definitely every algorithm will give the result with respect to particular data set. So it does not matter. It depends on data set only. Suppose some algorithm may give result support vector machine. Some algorithm may give result by CNN. Some algorithm may give result by KNN or different classifier. The reason is the condition of data set and availability of how much data set we have collected. If it is 5,000, okay, the training would be on 5,000. If it is 5 lakhs, that means more depth training we have done. So according to our requirement for our problem statement is quite clear. We need to perform the binary classification. Binary means we have just only say healthy or non-healthy. And under that, whether the tumor is hereditary tumor or non-tumor. So there are several methods are available in machine learning which can perform this type of classification as we have utilized some of them. But one of the major point I can tell if you are using suppose MATLAB. So MATLAB to classify for machine learning, MATLAB would be very easy instead of Python. Why? Because MATLAB we have multiple options of classifier. Directly you have that analyzer would be there, GUI would be there. Under the GUI, you can apply various feature extraction technique as per your requirement. After you will extract perfect feature or best feature, you can feed to the classifier. Now classifier type, you should not worry about the classification. Automatically classification will take place and classifier will generate the accuracy or other performance parameters. Okay, automatically we can say 5 classifiers you cannot apply with respect to Python or you cannot develop. Directly the tool will tell which classifier is giving higher accuracy. So that we can do it. So ultimately the data set from the brain tumor detection we have collected from Kaggle. Okay, so this is a generalized application I am talking. I am not talking with respect to research or set of us. Okay. So in this case, dataset consider MRI images. Dataset contains training and testing dataset which contain MRI images with no tumor or hereditary tumor. Training dataset we have no tumor 395 images. Hereditary tumor we have 827 images. Testing dataset we have no tumor 105 or hereditary tumor we have the 74 dataset. So according to that, we have split the data set into training and testing. So we have three categories if you have when you are developing a model. One is training, one is validation, and third one is testing. So validation and testing, there is one difference will be there. Validation does not require label data. Okay, and testing data will be without label only, and validation data will have label, but utilized for testing purpose only. Sometimes we are making validation also, sometimes we are not using validation. Directly we are splitting data into two parts, training and testing. So here we are utilizing, mostly we are utilizing 80% data for training, 20% data for testing. This is our condition. So data set divided two parts, one part for training. So 80% data used for training, 20% for testing. Data set displays training test. And training test split function is available to Skylearn, this model selection package. This is the code we can utilize. Mostly we are using in terms of Python, xtrain, xtest, and ytrain, ytest. So xtrain, xtest. So x means your data, training and testing. Y means label. Ytrain, ytest. So label also will be collected. Suppose you have 5,000 images, so you have 5,000 labeled it. So we can apply train, test, split, x updated while randomly we will start 10 and test size would be 20. By this method, we can divide the data, we can split the data during training time. Now, this is the logistic regression model we have implemented. So we are using, these are the packages we are using. We are just Skyline the model import, Skyline SVM import. Now print training data, testing data. Now training and testing data will be printed. So this is the score 1.96. This is score 0.989767. Similarly, convolutional network, as I said, we are applying images. So under the images, as I said, what is the procedure for CNN? So CNN consists of various hidden layers, various convolution layers. Every layer will responsible to extract the feature. So suppose you had a three layer, so three layer will be responsible to extract the feature. So first you extracted the feature. After that feature, you are applying convolution operation and pooling operation. Then you are using various activation function. So various activation function will responsible to extract the feature and just limit or threshold the feature. That is the purpose for. So suppose you are using ReLU. So what is the purpose for ReLU? Whatever the negative values would be there, remove it. We'll consider only positive. So rectified lower unit. That means only positive value will be considered, remaining negative value will be rejected or discarded. So by that way, all positive value will be given dropout. Dropout means sometimes we have multiple neurons. Some neurons are not responsible to extract the feature or extract the particular processing unit are not responsible to perform the operation. So what it basically will do, we will drop out 20% neuron. That neurons are redundant, we can remove it. So that we can do multiple times, drop out 0.5. That means 5% neuron will be drop out. After that, you can apply soft max layer. That is what that layer will provide the probability of whatever the output you expected from this classifying layer. Last layer will be classifying layer. So before classifying layer, that is called flattening layer, dense layer. That layer will be responsible to flatten. That every value will be single node value. So it will be converted single node value. And every value will provide, so here we have two value only, 1 or 0. So we can classify 1 and 0. So we can apply different type of activation function to classify. We have tested 10 reports. Someone has asked 1 minute has taken. The question was there, yours. So 1 minute has taken 1 minute. How much time filter will apply? Suppose 10 filter will be applied. Okay. So according to CNN, we are using 3 layer. 3 layer, but every layer 10 filters are responsible. So each layer 10 filter means 10 filter will extract 10 filter. Second layer also 10 filter. Out of 10 filter, we have to apply the activation function because some of the values are not required to remove it. So we have discarded that value. Positive value will be considered, negative value will be removed. So similarly, you are using dropout also. Sometimes the feature. Now this feature need to classify. Classifier means we can apply fully connected neural network. FCN. What is fully connected neural network? That means ANN. What ANN will do? It will flatten the layer, will convert multi-layer into single node layer. Single node. So every node will have certain probability. Based on the probability, softmax, one of the active functions will decide either binary class or multi-class. So where we are using softmax, that means it will be a problem of multi-class. If you are using sigmoid, that means the problem of two class. Binary activation function. But if you have multiple class like fruits, 5 class, 6 class, you can use softmax. Softmax layer will tell us probability of each outcome. Suppose one outcome 90% probability will be there, 0.9 probability will be there, then machine has classified first value. First value is apple, so apple has classified. Second value is banana, so 0.9 is banana, then banana has classified. Last value, any value has classified according to that. That is the case would be that. Now what about iterate? Suppose in your data 100. So you have to, I already told you split the data 100 into two parts, 80 and 20. Now you have to show machine 80. So what exactly? First, you have to feed the machine first image. What machine will do? Multiple filter will be applied on the entire image. So 10 filter, 10 feature has been extracted. After dimension reduction, 5 feature reduced by next pooling, by average pooling or any pooling layer. After that, 5 feature will be applied. Next layer again, next 5 feature, medium layer. Last layer, next 5 feature. Total 15 features. Obtain, connect all feature one line. That means single node. Then based on that, we'll flatten the layer. Then again remove the dropout. So first image has iteration. First image has done. Weight has identified. Second image has trained. Weight has identified. Third image has done. So epochs what exactly will do? It will train the 10 images. That means 80 images by 10 times. And 10 every time training first 80 images first time 80 images will take. So we have considered 80 images by 80 times how many images you are taking. So that would be a base size. So suppose you have taken base size is 8. So 80 by 8 is what? So for at a time how many images are coming? First is the iteration 10 images, 8 images. Okay. 8. So first you are training 8 people. 8 images taken, train your brain. Another 8, train your brain. Another 10, train your 10 epochs. Every time 8 will be taken, and finally we reach the complete image has trained. So 80 times how many image you are taking and how much you are training. So 10 times you are training. Every time what you are doing, every training, weights are modified. Epoch 1, weight was modified. Epoch 2, weight was modified. So during training time, machine will find out perfect way to recognize the predicted output and exact output. Matching with exact output, that is called error. Who is doing this task? Optimizer. That is optimizer will be there. So ultimately, we are learning something by optimizer. That is by optimizer weights are modified. So after 10 epochs, your perfect weight has achieved. Then you receive accuracy 99. After 10, if you are applying 20 epochs, accuracy won't change. That means your brain has trained. And it may be possible your brain, your machine, your model will become overfit or underfit. What do you mean by that? That means accuracy may vary. After 11, it will become 50%. After 12, it will become 80%. After 13, it will become 50. Deviating. So what do you mean by? So I will tell you when we are training the model. So according to model, we have this image, and we had applied this CNN layers. How many layers? 10 layers. So we have taken first this area. No feature. This area. No feature. This area. Now objective here. So this area feature is more important. So you are having 80 images. You are applying 10 iteration. So 8 images per iteration. First you are modifying, so your layer would be like that. First layer, second layer, third layer. And finally, you are having one single node. So every node 0.9, 0.0, 0.0, 0.0, 0.0, 0.1. So we classify it. We'll apply software layer, will tell us this is how many class problem. 1, 2, 3, 4, 5, 6, 7 class. So according to that, finally this final output will tell us what is the loss. And here the loss will reduce. Loss will reduce means A. So 10 minus 10. What is your exact output? 10. What is projected output? 10. So loss would be 0. So what you receive? 5. 10 minus 5. What is error? Again go back, change the way. Who is changing? Machine is doing by iteration. It's the iterator. That is called back propagation network. Back we are going changing the way, coming back, checking the error. Error is 0. Stop it. So first information has trained by machine. This is object. This is not object. Again, machine will train another few objects. And as completed train, our object has trained, machine has trained by 99% accuracy, which is only 1% error will be there. Now we are doing 20% testing. No label. No predicted output. Just they ask, what is this? Machine will tell. 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 If our 4 objects out of the 3 has been detected. So what is accuracy? 80%. That's all. So that is the process we are doing. That is called validation loss and testing loss. Loss means by changing the weight back and side and providing the correct weight, and that weight saved. Tomorrow if you train again, same weight will be there. That means machine has learned whatever the example you have trained. Now that weight can be transferred to another example, that is called transfer learning. So whatever you are learning every day, you have learned one time, you will not forget. Your brain has trained at that weight also. So your machine has to train by that weight, and that weight needs to be recognized by the learning rate or by the optimizer. Optimizer, what exactly doing? Reducing the loss by changing the different ways. So ultimately, in this case, we have seen accuracy CNN 99.2. Conclusion: compared with SVM. So 2 are machine learning method, 1 is deep learning. Similarly, this loss has reduced. But sometimes if it is overfit means your graph would be like that. I say you receive 90, 50, 70, 30, 20, 40, 95, 25. The over underfit model, not fit properly. If loss has to reduce, accuracy would be like that, na? But suppose if it is reducing like that, it's not going to convert. So it stops the iteration here. This iteration is 20. After that, no need to train after more iteration. Stop it. Model has trained. Because what happens if you are training unnecessarily, result won't change, it will become overfit. After some time, it won't provide proper result. It will provide mistake. Understand? So now the next application is lung disease prediction of COVID-19, lung obesity, and viral pneumonia. Objective: we have designed machine learning model as per our requirement. We have new raw images for various lung diseases, build a learning on the provided images, and able to precisely classify the new input X-ray image. So we have utilized image classification problem. This is the image classification problem. We have utilized support vector machine model, K nearest neighbor model, raw X-ray images are there, and we have coded in Python with the data creation, model generation, and multiply. This is the block diagram. Under that, training the data of different images, pre-processing, model generation, generate the model based on the SPM, KNN, the testing images, X-ray, and that generate the result accuracy and Apple score. These are the images are available: COVID-19, viral pneumonia, lung obesity, and normal pneumonia. So we have knowing data set, four category of information are there. So this is the how many class problem? Four class. So we have four classes: COVID-19, viral, lung, and normal. So it is application is general classification problem. Data is used for model generation. Set of raw images labeled under the folder. So this is the COVID-19 images in a infection disease caused by the severe and acute respiratory syndrome, coronavirus 2. Chest X-ray has collected in the diagnosis, detection of the complication and proliferation of corona disease. This was the 2019. So chest X-ray examination will lead to both false negative and false positive rate. Now here one more thing will come out. Performance measures will change. I may detect he as a he may as a she as a he, she as a she. What condition would be there? So positive value will be detected positive, called true positive. Positive value would be detected negative value, false positive. And false value will be detected positive, true negative, and true positive. So true positive and false positive actual value. True will be true and false will be false. But false value detected positive and for negative value will be detected false. False value will be detected positive, positive detected negative. So that is the loss for accuracy will reduce. And suppose someone has not having pneumonia and detected pneumonia and given that medicine for pneumonia. So wrong. So it should not happen. But definitely this result may come by because human may do error. So that's why false positive and false negatives are impacting the algorithm. So this is the lung opacity images because of pulmonary specification. You have to collect the data. This is the viral pneumonia images. You'll see the images are available. So infection of your lungs caused by the virus. So image will be looking like that. Similarly, this is the normal images. Finally, data set generation get applied through Python, through Jupyter Notebook. Now this is the model generation. Now we'll see here. This is the confusion matrix. What confusion matrix will tell us? COVID as a COVID detected 129 times. But COVID has detected other model. Lung opacity detected as a COVID also. It may be detected 131 positive, but other are negative. Similarly, normal as a normal detected 137, but remaining are 3 detected as a COVID-19, 6 detected as a lung opacity, and the last 17 detected remaining. So COVID as a COVID detected 129, lung opacity detected 131, normal viral pneumonia will be detected like that, and finally viral pneumonia 140. So these are the 4 conditions and it is detected like that. So these blue are true and remaining are false. So this is the model accuracy 88.90 for FPM. Following are the confusion matrix. So this is the another confusion matrix without normalization with normalization. This is the predicted result. How this has been detected? Predicted value is the actual value. This is a label. So COVID is a COVID, right? Normal is a normal, right? Lung is a detected COVID, wrong. Lung is a detected lung, right? Likewise, this label is the actual value, and this is your predicted value. Now, what exactly you have to do during training time? You have to change the weight and you have to find out exact as X. That's right. So this is the KNN model. We receive the accuracy like that without normalization, with normalization. Similarly, these are the result, prediction result. This is the deployment of model. Then we have detected this image. So this image detected shown corresponding to COVID-19. This is the testing. Without anything, just we have detected COVID. This image detected as a COVID during testing. Now, another last problem we have seen breast cancer detection. So we can see in that case, common statement for data set having data for various attributes related to breast cancer like radius, texture, and perimeter that will be utilized for feature extraction. So we require a perfect machine learning model which can be trained using the given data set and which will provide an accurate prediction for test input value whether the cancer is malignant and or benign. Now these are the algorithms we have utilized. They are all classical algorithms, logistic regression, support vector machine, decision tree classifier, K-N, K-DSN. So data set gathering and description. So data set of the breast cancer is taken from Kaggle available in CSV file format. So data set would be there in different formats, utilized in CSV format. And data set consists of total 32 columns, one column for all topics for various cancers, attributes, remaining one column target volume, which tell us whether the malignant will be there or benign will be there. There is no missing data in this data set. Now, these are the ID will be given. These are the remaining 30 columns. Attributes are related to that. We have imported certain library. We utilize certain data set, and then we have find out this data. So we read the data from data set. So we read the data from data set using the library, created data frame and cancer. First 5 entries the data set also shown like that. We'll see these are the data would be there. Now column ID is irrelevant in our prediction. So hence we remove from the input variable. Column diagnosis is our target column. It has given to output variable Y. So remaining 30 columns are the attribute based on the prediction will be done. So hence we are giving input variable X. These are the performance metrics. 94% accuracy, 94, 91. This is the 96.50 highest by 10. And this is the confusion matrix. 87, 1, 4. Actual would be 87 and 51. So this is the related to medical imaging was there. Now I would like to move practical section. Yeah, best side depend upon the your data set. I show suppose if you have data size is 15 is 40+% out. So 40,000 units is 34. 1,000 units is 8. So suppose you have 1 lakh 6,000 plus 20,000. 64 or 128,000. So depending on the size of the data, you can use it. That is your own prediction. But if it takes less time, more prediction will take little more time. During training, it will be. And people have one problem may come in models may overfit. That problem may come. But sometimes your model is running well. But after model be overfit, then your result will be negative. So you cannot retain whatever the model is trained the previous way. Directly result reach 92% accurate. Suddenly it reached 75% accurate. That means model has got a problem as arrived. You need to wait finding. So that should not happen. If you need to test according to proper way. So now we'll move towards the practical wise. The one minute. Image second first. Enlarge. Zoom close. Website. So this is the we have developed the model. We can see here load the model, import numpy is a numpy. These are the libraries, and we are just keeping the running. So it's a running mode. Import pandas, import matplot library for plotting purpose. We are using import timeline for splitting the data, timeline for accuracy score. So all these libraries are supporting while writing a command. Whatever the keywords will be utilized, these libraries will support. Now Google Colab we are using. Why Google Colab? Because we are running through our Google account only. So in the Google account, this code would be there. So we have mount the library. So automatically it will connect to our Google Drive. In the Google Drive, data also would be there, as well as our code also would be. So it does not require to open your system. Automatically you can open your Google account. Just open the Google Drive. Google Drive code would be there, data would be there, but you should have the size. That memory will be occupied by Google Drive, so you have to buy the Google Drive. But as per our institute, they have provided more than 300 GB data. We can share our memory there itself. So as per our requirement, now collect the data. We need to run import operating system need to be attained. Path will be collected, connected with respect to where the data set would be there. And classes also would be connected, like how many classes are there. So we have two class problem. Now after that, we need to import CV2 library. CV2 library, basically it's a computer vision library, has been utilized to understand the whatever the computer vision commands are utilized. So we'll see path, we'll see the data from there. Image will read by CV2 dot image read. Image will resize, append the. Now this will run. That means it will show this arrow. Now this is the unique. After the numpy array will be created for x and y value. Then this series value will be counted. These are the steps will be applied. Now shape will be considered for the image. So we have that much images. Size of the image will be 200 into 200. After that, visualize the data. We need to see the data. So we'll go for plot.imshow. By that way, we can see the image. This is the visualization of the image. So this would be available in data set. We can see the image. Okay. Now next, we can prepare this according to that. That means this data updated by reshaping. Then 1200 or this data would be condition will be available. Now split the data. Now go to next stage. Now see, these are the shape versus data would be there. So now we have to train and shape, test and shape. So we have this data and the shape of the data, and this data will be shape of the data. After that, feature scaling will take place. So we have the feature scaling, print this data, train data, test data, and then we can see this extend dot minimum value, extend dot minimum value. This would be shown. Now we had applied feature selection by using of principal component analysis. That is called dimension reduction technique. So we had applied PCA, and build command of the PCA would be there. So we have just get it PCA by this value. Now after that, we need to train the model. Then SVM will be applied. So feature extraction, selection, then training with different classifier. So we have seen three classifier: logistic regression, support vector machine. So we have seen that support vector machine with the data after PCA applied, and this PCA training and Y training. Next, evaluation. So evaluation will be applied print, training score, print, testing score. So this is the one that is 100% accuracy, testing 0.95. That is 100% trained, but accuracy received 95%. Now after that, code by this is logistic. This is support vector machine. So testing score 0.99. So training and testing score 0.95. So this is the more accurate. Now prediction, we can just test this by using of prediction. Yeah, so these are the array would be there, classes would be there. And now we'll see prediction of 36. Which one? So we'll see 0. So this 36 means it shows 0. 0 means no cancer. And image number 36, again testing will show 1. That means cancer would be there. So it will show the prediction wise 0, but testing wise 1. Now we have to apply the testing. 0 means no tumor, 1 means positive tumor. Now we have to call our whatever the directory we have saved our file. We are after training and testing is just training. Applied. So it will show the image and it will apply the no tumor, no tumor, no tumor. No tumor, no tumor, no tumor, no tumor, no tumor. Now again plot. Yeah. So in this case, see positive tumor, no tumor, positive tumor, no tumor, positive tumor, no tumor. So this is the testing wise we are getting the result. Yes. So this way we are developing the model. But this is only generalized model we are not paying any research kind of thing. You want to do research, you have to develop the model as per your requirement. Your data set well, because we have very small data set and due to the limitation of the data set, we have to just change the algorithm. So please show the next part. In so directly day one people. Day one. Every patients it has taken. Yeah, for that we need to apply the particular code. I will show that. Actually, I am able to run by own workstation. So it is virtually I have to show that connecting to system. Go to day one. Day one. And hit day two. Video won't change. How it will change? Change. You change it. So I'll discuss about how the convolution will work. We'll see first that part. Just go through. So convolution neural network will consist of convolution operation, and by the convolution operation we are expecting image features. And under that, image features will be modified by using of various hyperparameters, depth, stride, and padding. After that, we are removing certain values by using of value activation function. Then pooling will reduce the dimension. That means it will reduce the number of features. After that, fully connected layer. That means ANN. What ANN will do? It will just convert into one node. After that, last training the CNN and designing more CNN. Go to the next part. So in CNN, we have seen with respect to understanding of neural network, we have designed A into W1, B into W3, C into W3. W1, W2, W3 was not created. Now you have big image. Size of the image will be 1024, 1020. Into color into 3. So how much data will be there? Okay, suppose we take 8 into 8, 64, color is into 3. So 64 into 3 pixels would be there. So likewise, size of the image 64 into 64 into 3. That much pixel would be there. So that should not be possible if you are using simple ANN. So that means CNN tell us neural network cannot be scaled well into image data. because image data is very huge data. You'll see this is the size of the image. 9 cross 9. 3 value. Every value will consist 3 value. RGB. So according to that, how many value would be there? 9 into 9 into 3. So according to our requirement, how much operation will take place? So we have seen image will store at a time one value. If it is gray image. But if it is color image, it will store 3 value. So according to that, color image consists of 3 value and grayscale consists of 1 value. Now I said if your image classifier you want to classify, you have taken size 64 into 64. Now input size 64 into 64 into 3 is 1200 to 88 pixels are there. If you multiply every value, how many? So ultimately, therefore, input layer are required 1200 to 88 weights. Every value will be 1 weight. Now, not only large amount imaging using input, suppose 640 into 480 and into 3. So how much weights are required? 9,21,600 weights. Add some more hidden layer, you will see how fast this can grow out of control. After some time, it may go out of control. The image, more pixel, more weights are required. That means it cannot be scaled. So image data need to be scaled. So according to our requirement, what we are doing, we are changing the, and this will take huge amount of training. And this it will take 10 days, 1 month, year. So that's why we are going 3D layers. That means convolution can, by applying the convolution, we are learning the feature. So simple example, I have taken one image and I had applied one convolution operation on that. So you know very well what do you mean by convolution operation? Image direct multiplication. So 3 by 3 matrix will multiply 3 by 3 value. At a time 9 value has covered. That is called first feature. Second time you applied here. Calculated 3 cross 3. Received again 9 value. 9 has covered. Again next 9 has covered. Next 9 total how many value has covered? 9 into 9 18 27 plus 27 plus 9 36. So 36 value has covered at a time. But 36 weights are required if you are doing individual calculation. But how many weights we use? 4 weights. So we have taken in fast scale. So by that way, we are using 3 conditions. Image data consists of height, width, and channel. Channel means 3 values. At this 3 values, value would be there. This type. This is called image data. Height, width, and depth. What is the depth of the image would be there. So I'll write in terms of this. This is the model I will implement. I want to classify cat as a cat. I will implement input is this image. I'll apply 1, 2, 3 filter. Convolution layer. This is convolution layer plus RALU. RALU means calculation 100, remove 20 negative values. Another pooling. Pooling means half the value. 50% has reduced. Again convolution plus RALU, pooling, then fully connected. Fully connected means all will be one line. All feature will be one line. And we got 0.40, 0.50, 0.20. We classify cat is the maximum probability. Cat has maximum probability. We classify cat as it. But this area feature is relevant. Will tell us cat. Remove it. This area feature relevant. So this area feature will be obtained by tool. You see the operation. Before divide the convolution, we'll see the feature. What features are there? We have this feature. What is this feature? Age features. So we'll apply the age features, color features, pattern, shapes. These are the features. Next, we'll see the different methods. Before CNN, featuring was done manually. Then one of the person asked, sir, can we see the features? You apply PCA, one feature. Apply HOG, one feature. Apply SIFT, one feature. Apply SURF, one feature. No need to apply. One convolution operation will give the feature directly. One convolution feature automatically will detect 3 layers, 10 times filter, 10 features. Only to apply SIFT, PCA, all the steps techniques. You want apply it, but connect with machine learning to deep learning. If you want extra feature, apply that. That is manual feature access. But this is not manual. This is feature learning. I learned to prepare chicken curry. Now, by the knowledge of chicken curry, I can prepare mutton curry also. Procedure would be same. So I will not forget. So that means tomorrow, one more cat picture you have taken and you want to test your machine, she will detect. Because this is the procedure of feature learning. That is the major difference between machine learning and deep learning. Machine learning features are ready-made, handcrafted. So handcrafted, new feature will not be obtained if new object will come. But if you are having every day you are learning and you are identifying that is called adaptive feature learning. So deep learning is one layer and responsible one feature. Tomorrow one more layer will be added. Tomorrow, day after tomorrow, you will have one more new layer in the same technique. Feature. So that is called adaptive. No need to go handcrafted. So that was the main problem in traditional machine learning algorithm to deep learning. So only deep means what? That. You are in 5 layer, 6 layer, 7 layer. That approach would be up. So we can say here HOG failed, binarization failed, all methods failed. Now if you are applying the conversion operation. So before CNN, feature engineering was manual. These are the features are there. You will see these are the features. These features will learn by the machine. It may be different way. Now, after conversion, whatever the output matrix would be there, that is called feature. 24 into 24 matrix, you are applying 3 cross 3 timeline. How much time will it take? 5 times or 6 times? 6 times. So 6 times 6 features. Complete operation will take place 6. Suppose value would not be there, what you do? In single process, what you are doing? 0 5. Padding you are doing or not? Padding will be applied. So that means you can apply the 2 multiplication of 2 matrix will tell us final output is called feature map. And each filter will be responsible to extract the feature that is called kernel or filter. Multiplication. So weight matrix will be a what? Filter. Weight, or we can say kernel. By every multiplication we get various features. So we'll see here. It's a simple sliding process. What we are doing, I am taking one filter here. I am sliding like that. Like how you are doing painting. Like that, like that, like that, like that, like that, finishing entire wall. So I'll start from here. Take convolution, 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 convolution. I'll start from here. Take convolution, convolution, convolution. Is it also possible I may take here, 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 and here? Possible or not? That is called strike. I may take consecutive or I may drop somewhere. Or I may take here, here. That would be that is the approach we are changing. So sliding process, simple matrix multiplication. You will get it by exercise. That is image, that is convolution filter. First kind of filter, who are deciding? There is like modeling. We cannot. Our brain has trained one question, your brain has trained by 10 minutes, my brain has trained 20 minutes, it's my rate. Your rate. So this matrix will be available when you are doing training. So first iteration, first time, you will have this image. So three value will be considered, first three multiply first, output will be here. Second three, output will be here. So how many output will be obtained? 9. If we multiply individually, how many? 9. So we got this 2, 1. So likewise, we have 1 log. 9 times multiplication. Now this 9 value also can be reduced to cross 2 also. So what we will do, how the effect of kernel would be there. Kernel means in image processing, every kernel is having the important. If kernel is utilized for A detection, that value is -1, -1, -1, 0, 0, 0. If you have Sobel filter, Robert filter, Privet filter, image process. Same way we are having various filters. See this. And this filter will tell us age will be there or sharpening filter would be there. So this is sharpening filter. This is sharpening filter. This one. 0, -1, 0. This is the nature of the output will come. This is called age detection. This is called identity detection. This is called box blurring, image smoothing, and this is called Gaussian blurring. So such kind of filter will be available backside. Multiply and get it the result. Machine will not apply unknowing filter. Machine will apply such kind of filter only. This is based on the rate. And we will get ages. These ages will come. If you are face recognition will be there. If hair recognition will be there. Anything, so ages is important. So ages would be low level feature. But final high level feature is what? Texture of eye, texture of nose, texture of lip, texture of chin. That's it. So finally, this will happen. Then conversion operation. We need many filters, not one. Just not one. So 12 filter we applied like that. 12 times 12 filter, 12 filter. Now finally, this would taken care like that. See, like 12 times on single image, 12 filter will be applied. 12 different filter, 12 different filter. So understand how filter will come? We cannot recognize this. Finally, we'll see after this we have really that cannot be done. That cannot be done because we cannot see also what weight has looked like. Weight has saved in terms of some different formation. So weight file will be there. So suppose you have trained your model, that feature already trained that model. Now that feature again you are retrained, same feature will not come. Same feature will not come because weight has changed. Because this will be done by optimizer. You are using optimizer like stochastic gradient descent, SGD, or if you are using RMS prop. So RMS prop are finding different weight, SGD is finding different weight, so ultimately your result would not be made with that. So now output of conversion would be 3 cross 3, now it will be 2 cross 2. How? So how many filter would be there? 12. So the result would be like that. See, these outputs are total 3D matrix. Output was 28 into 20 into 12. 28 into 20, size of the image, and into 12. See this condition feature. After that, we'll apply activation map. We'll apply the activation map. What exact activation map will do? We receive positive and negative value. So what you will do? Negative value will be remove. Plus one will be considered, minus one will be removed. So you are shorting now. Minus side will be eliminated. Only plus. So it will be applied like that. This is the we have seen arbitrary side of it 3 plus 3. We have choose the what can be changed. So depth, stride, and pattern. Depth means size of the paper. 3 cross 3, 2 cross 2. Stride means how you are multiplying. I am taking 2 gap, 2 gap. I am not taking gap directly. I am overlap. So I may consider 3 cross 3. I may consider 2 cross 3. If I consider out of you, if 9 values are there, I take 2. Not overlap. 2. How many operation? 4. If I take all 3, 2, 2, 2. How many values? 9. So image may be 9 cross 3 cross 3, 9 values, or image may be. So that may be changed. This is the hyperparameter C. I am designing the feature map. How many feature map will be there? 9. If I am doing continuous mapping, like that. So we have the designing feature map by using of this parameter. Kernel, size of the kernel. How many times filter you are using that. Stride. How you are overlapping. You are using 2 cross 2, you are using 3 cross 3. Or padding. Padding means if the value is not there, consider 0 and 1. So this is the depth. How many times we apply? 12. Yeah. Now stride. How you are multiplying? No gap. Second, third, fourth, fifth. No gap. If value is not there, consider right. 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 Right to change. So previous case, how many value came? 9. In this case, how many value will come? Because I am dropping this one now. 4 times only operation will take place. So what is the size? 2 cross 2. 3 cross 3, 2 cross 2. Now we can change 0 padding. So 0 padding means we are doing like that. So 0 padding will consider border. So we can set padding either 0, either 1, either 2, either 3. Any types. So 0 padding will make image larger. Larger. Now this will create the final output. So it will become one formula. This I minus A plus P by S plus A that stride P and I. By using this design will be collection. This is called hyperparameter. Now ReLU, see the ReLU will do. This is called activation. We need to introduce non-linearity in the model. We need to apply activation function. See, negative value has been eliminated. No negative value. All are present. Plus value will be there. No minus value. See, if you apply ReLU, any negative value is there? Minus 1, minus 5, minus 5, minus 1. Deal. Remove it. So this is the mathematical things are going on back. Pooling. So pooling is reduce the dimension. So this is the big image. Take maximum pooling. Which is maximum? 234. Keep it. Which is maximum? 167. Which is maximum? Which is maximum? How many sides was there? 4 cross 4. What is size now? This is final picture map, sir. final, small. This will be 1. Then next layer also will do same operation. Another picture map by dimension reduction. So dimension reduction means the entire feature are not important. This is important. This is important. This is either you can do average pooling. What average pooling will do? Average of this, average of this, average of this. So various pooling will be applied to reduce the dimension of the output. See, this is the final model we have this. Image size, filter size, number of times, stride, depth, put padding, apply, feed the input, another ReLU output, back pooling, that is called down sampling. First layer. You will apply this kind of thing. More on pooling, you can apply various pooling with no put padding also. Now finally fully connected layer. Fully connected layer means single node. Multiple value, parallel value will become series value. It will become series. So fully connected layer means simple neural network. ANN. So all layer will be fully connected. This is called fully connected. 10 apple will become 20 apple. One size. And every value will give certain probability. Then choose which is having higher probability. Classification. Done. This is the general problem of classification using. So like that, various models are available. Is 16 layers are available. Is 19 layers are available. ResNet 50 layers are available. ResNet 121 layers are. Now if you have choice, you can use as per your data. You can delete or you can add. Yes. You can twist the value. What you can twist? Hyperparameter. And how this training will take place? Finally, the scene. Softmax final activation function. Softmax will tell us node number 1 probability 0.3, node number 2 probability 0.6, node number 4 probability. By this activation function, we may receive various probability outcome. By this way, we will get the result. If you have multi-class problem, Softmax will be responsible. If you have 2-class problem, Sigmoid will be responsible. Okay, so multi-class means 5 class, 6 class, 7 class, more than 2. Now finally, training. How we are doing training? This was the traditional model. Low level feature, medium level feature, high level feature, feed to the classifier. Earlier problem was traditional problem, we were doing like that. We were getting every feature by feature accession technique. So one of the person asked her, can we see the feature? At that time we can see the feature because feature was calculating by transform, HOG or SIFT or SURF. So every feature will be treated like that. Now we'll replace by CNN. Now what CNN will do? Like that. This layer, this area is feature. Reduce feature. This area is feature. Then all feature will be one node. Tell us probability class. So training, how we are doing? First layer, which weight will be analyzed? Random. Random kernel will come. First line 1 1 1 1 1 feature 1 obtained. Forward propagation, you are moving this direction. 10 times 10 filter propagated, 10 filter obtained, 10 feature map. Convolution, ReLU, pooling, fully connected. You have reached. Now you did not get correct output. What you will do? Go back, change the weight matrix, calculate the error, then this output tail. Then probability 0 1 0. Then go back, change the weight, then get the result. So likewise, how much time you are doing until your loss will reduce. Who will do this task? Optimizer. Optimizer will check correct weight has obtained or not. Once you have saved correct weight, Stop the model. Save the model. Now model has saved with respect to weight unless and until you will retain the model, your model will save on that weight. It won't change. But if you have received new data or new information, again change the layer. Change the layer and repeat. Then you will get it. So you have seen here, keep propagating through the all network, epochs will complete. One epoch complete, one training is over. Again go to train. Again go to unless and until you will get zero error. Loss will reduce 0, 100%. That approach, yeah. That is the training procedure. So keep continuous training till loss and accuracy are satisfactory. So our design our model. So how we design our model? Input, convolution, ReLU, pulling, FC output, one layer. So we are setting like that. We are setting parameter, input layer size 28 cross 28 into 3, 64. This is the image size. Now we'll choose the downsampling. Typically 3 cross 3, 5 cross 5. Stride we are using 1 or 2. Zero padding we are using. Pulling we are using 2 cross 2. Dropout we are using as per our requirement. This is the creating one. So our layer convolution ReLU pulling. Convolution ReLU pulling. How many layers? Fully connected output. This is neural network. This is output. Softmax. That's all. So convolution ReLU pulling. Convolution ReLU pulling. Fully same way we need to write in program. So can you show the program? 1 minute. I'll show. This is the model. Now we have to evaluate our model. So we have to generate the probability. Model.prediction function will generate the probability. Then this is the one example. These are the data set we have. This is called MNSID data set. This data set was generated by US Army to know about postal code. Handwritten recognition. So this handwritten would be collected. Size is 60,000 training, 10,000 testing. Now, problem aim is this data set developed by US Postal Service needed to automatically read the postal code. And aim of the classifier, digit need to be classified 0, 1, 2, 3, 4, 5, 6, 7, 9. This is our model. Now I will tell you easily we can understand the program line 1 model.8. Convolution layer filter 32 times. Convolution layer 64 times. Pooling layer 64, dropout 0.5, 0.25. Flattening layer, fully connected layer, dropout 0.5, fully connected layer. This is the multi-class. How many class? 9 class. 0 to 9, 10 class. So this would be there. Now load our data. I will show the program. This is the program. Form Keras. This is the package. We are using Keras plus TensorFlow as a package. Here load command would be there. MNIC data will be loaded. .MNIC data. Data would be there in 2 categories, training and testing. So shape would be there 60,000. Size of the 28 cross 20. This line will complete. You have to run. Your data will show this last line out. Now next line. Encoding the data. 0 to 9 number would be there. So we are using, suppose your data would be in the particular shape, size 28 cross 20. So convert 60,000 28 into 28. And you should know comma 1 not written. Why? Because these images are gray image. So we are not declaring the depth. But if it is color image, you need to declare the depth. So we are using or 1 encoding. That means how you can represent 1 as a classifier. I have 9 number. Easily I will tell you 0, 1, 2, 3, 4, 5, 6, 9 positions are there. If every position 1 value will be there, I will classify. If 0 is high, I say 0 number has been classified. 1 bit is high, so I have to represent suppose 3 number.
3. So what I have to do? 0, 0, 0, 1.